Hello, this video is going to be about the clearance arms and also the same arm that holds the electrical connector. So I was just in this mode of creating arms for everything that I could see, and I looked at the electrical connector and I'm like, well, maybe there's a reason why we would want to move that around. Turns out there was a bunch of reasons. For one was like VAV boxes. So if we look at the VAV box family, this VAV box has a panel, a control box that can either be on the right side or the left side of the equipment with an associated clearance. So if it's an electric reheat box, this clearance depth changes as opposed to just being a hot water reheat. So that was the first case where I found that, hey, there's a need to have an arm for an electrical connector and move it around. So let's develop the parameters and let's give that to the electrical discipline. So this will be the first showing of the motor family that was developed for the shared model, the MEPPP shared model. This family was developed for electrical to use that is a mechanical equipment family. I guess I was going to show you guys where it ends up. So it is a mechanical equipment family, but now this allows us and them to use a common schedule for all pieces of equipment that have power, as opposed to having some electrical equipment and fixtures and things like that. So let's go back to the family and find out what the arm can do. So just like everything we've talked thus far, the arm now has two visible protrusions. It has a head, and now instead of, well, this is holding a connector, but it also has a clearance volume that can be turned on or off in the project. It can also be turned on or off in this family. So now we can apply the same functionality and we can move the electrical connector around along with any associated clearance. So maybe this would end up representing a panel mounted to a rooftop unit. Or maybe it's an access door that electrical needs to get to for servicing that may have a specific clearance tied to that doesn't apply to the rest of the family. So let's open up our parameters again, our family types. So we're going to talk about the calculations in here later on, but lots of cool stuff to highlight for electrical load calculations. So here's our arms. So, users can flex the equipment geometry if they need to. So we can flex that. And the arm is always staying with the outside of that geometry. So that's the first concept with these arms in the mechanical equipment families, is they follow the face location with no reference plane. So let's go back to one by one. So right now we have this, so the electrical orientation, it's a list functionality that I learned of from Sean Zerbies. So we can change this connector to be on the front face. Just like that. We can change it to be on the top face, or wherever we need to. So say, for example, we are on the right face, and say we have, essentially this is the same way it's going to function in all the mechanical equipment. So that's why I'm showing it here in a simplified family. And then electrical or any family creator can do what they want with it. Let's give this box some size. Let's make it 10 feet by 5 feet by 3 feet. So there we go. Now we've got a much bigger box. Let's zoom out and let's start moving around this box. So here's our faces, that apply to the arm. So right now we're set to right face. So when you do that, we have formulas built into the family that will ignore the X value when it's 0. So it will just go to the right face. So if we did give this a value though, so say we did say that this is going to be 4 feet from the center of the family, you know, we can move this independently of whatever the faces are. So full flexibility on where you want. Now we also are able to move the connector down the y-axis and the z. So when z is 0, this family automatically says it's at height divided by 2. But say we want it just above, say we want it, you know, at 4 inches, and we want this, the y coordinate, to be -3, -2 feet. So now we're back on the face, and now we've moved up 4 inches from the reference level of the family, and we're back 2 feet from the center of the family. So in the next video, we'll be talking about adjusting our reference point location to give you guys even more flexibility. This was meant to highlight the electrical connector. And I didn't address this, but you know, once again, you have full control over the head. So we can make a 12-inch by 20-inch size, and let's move it up. Or in this case, we could go back to 0 and put it right in the middle. And there we go. So full flexibility for this electrical connector, which will end up coming into play with actual conduit length runs and wire lengths, which we'll see down the road in Revit. Thank you.